So this is lecture number 11, and today I will be talking about mechanisms of formation of chaotic solutions of chaotic dynamics. So we will call it nature of chaos. And again, we will consider logistic map un plus 1 equals to r un1 minus un. So here u naught is again in the domain. It's a number in the domain from 0 to 1. And we picked up value of r. Now it is 4. As you remember, previously we have found analytical solution for logistic map in the case r equal to 2. And now we will find analytical solution for the case r equals to 4. We know that at r equal to 4, dynamics is chaotic. And to find this analytical solution will let us to understand how this chaos is emerging. So to find this analytical solution, we will use substitution. So first of all, un plus 1 equals to 4 times un1 minus un, and we will use substitution. So it is implicit substitution. U equals to sine squared pi theta. With this substitution, what we will have is, okay, so un is sine squared pi theta n. Un plus 1 is sine squared pi theta n plus 1. And using these two, we can find out how theta n plus 1 is defined in terms of theta n. So un plus 1 equals to 4 times un1 minus un. Now we replace un by sine squared pi theta n. It will be 4 times sine squared pi theta n times 1 minus sine squared pi theta n. So this will be, so we know that this is cosine squared pi theta n. Therefore, we will have 4 sine squared pi theta n times cosine squared pi theta n. And this, we will put it like 2 sine pi theta n times cosine pi theta n squared. So now we use another trigonometric identity. This equals to 2 times sine times cosine of angle is sine of double angle. This is trigonometric identity we know. And therefore we will have here sine squared of pi times 2 theta n. And this 2 theta n should be equal to theta n plus 1. Theta n plus 1 equals to 2 times theta n. Now let's make following observation. So we said that u is sine squared pi theta. So sine squared pi theta is periodic function with periodicity 1. Well, generally it looks like this. This is theta. This is u. So 0, 1, and then it will be repeating and so on. Therefore, we can say from here we can conclude that theta can be chosen in the domain 0, 1. And for theta, so now it's theta n. And for theta n to be also in the domain 0.1, we will define it a bit different way. We'll say theta n plus 1 equals to fractional part of theta n mod 1. So we will subtract every time after this operation. If we get integer part, we subtract integer part and only consider theta n plus 1 will be only fractional part of 2 times theta n. Another way to write it. So this is our new map. So again, theta n plus 1 equals to 2 times theta n mod 1. Mod 1 means we will subtract integer part. Only keep fractional part. This can be also rewritten like this. Theta n plus 1 equals to 2 times theta n if theta n is between 0 and half. And it equals to 2 theta n minus integer part, and integer part will be 1 if theta n is between half and 1. So this, it is the same map, just represented a bit different way. And if we consider plot of this map, theta n plus 1, we will see. So here it is a straight line, so theta n plus 1 equals to 2 theta n. It is straight line with slope 2. Here is 1, here is 0, here is half. And after half, it starts again from 0. So this is called Dublin map. Sometimes it's called jigsaw map. Let's keep it this term, Dublin map. So Dublin because we just multiply by 2 value of theta on the previous time step. And now to further analyze this map, let's see what is theta. So theta, we can start with theta naught. So we want to understand how dynamics depends on the value of theta naught. Theta naught is a fractional number, which is, it has a 0 integer part, 0 point, and then a1, a2, a3, and so on, and it is fractional part. For what follows, it's good to represent theta in binary system. So in binary system, AI can be either 0 or 1. So it is a digit, but this digit in binary system can have only 2 values, 0 and 1. And this means that our theta naught will be equal to a1 over 2 plus a2 over 4 plus a3 over 8 plus so on plus an over 2 to the power of n plus so on. Now let's see what happens with theta 1. Theta 1 equals to 2 times theta naught, which is 2 times a1 over 2, which will be a1 plus a2. Now it will be over 2, it was over 4, plus a3, it was over 8, now it will be over 4, plus so on, plus an over 2 to the power of n minus 1, plus so on. Since we remove integer part, it will be equal to a2 over 2, so we cancel it, integer part plus a3 over 4, plus so on, and this at the end will be 0.a2, a3, and so on, an, and so on. So what happened? First digit disappeared. First digit is gone. Then similarly for theta 2, we will find out that it will be equal to 0.a3, a4, and so on, an, and so on. So every next time we lose first digit on every next iteration. Now let's consider different cases of theta naught. Theta naught can be rational or irrational number. On the other hand, rational can be terminating or repeating. So let's consider first case. Theta naught is terminating rational. Which means that theta naught equals to 0.a1, a2, a3, and so on, a, say, k, and then it will be zeros. It's terminating. Then what it means? This means that, for example, so theta 1 loses first digit. This one. Theta 2 loses second digit. Theta 3 loses third digit, and so on up to theta k. Theta k will be equal to 0.00 and so on, 0. And this means that in fact, so it will be 0. Theta n equals to 0 for any n more than k, more equal to k. So this means that theta n tends to 0, and our solution is converging to 0. Second case, theta naught is repeating rational number. In this case, theta naught can be presented like this: 0.a1 and so on, ak, then ak plus 1 so on, a, say a, and this part is repeated, then it will be again a plus 1, and so on, a, n. So this is repeating part. So in this case, up to theta k, we will have kind of numbers, but what is important, theta k will be equal to a k plus 1 a n repeated. Put it here in power infinity, so it will be just repeating. And then from here we conclude that theta k will be equal to theta k plus n, and therefore we conclude from here that solution is periodic with period n. Let's look at some details of periodic solutions. Let's consider first two periodic solutions. Starting with theta naught equal to 0.01 repeated, yeah. Then theta 1 will, so in theta 1, so this is in fact 0.01, 01, and so on. So first digit should disappear, and we will have 0.10, 10, 10, so it will be repeated 10. And theta 2, again, so this digit disappears, and it will be equal to 0.01 repeated, or equals to theta naught. What are these numbers in decimal system? Theta naught, which is 0.01, it is in fact 1/4 plus 1/4 squared plus 1/4 cubed, and so on, which is geometric progression. 1/4. So sum of geometric progression, it is 1/4 times 1 over common. So 1/4, it's first value, and common factor is also 1/4. It will be 1 minus common factor, and this equals to 1/3. So this is theta naught. Theta 1 is 0.1010, and so on. This will be equal to half plus 1/8 plus 1/2 to the power 5, and so on. And here it will be equal to, first term is half times 1/1 minus common factor, which is 1/4 again. It will be 2/3. And what is interesting now, let's look at, so we have two periodic solutions, 1/3 and 2/3, and again 1/3, and again 2/3. Let's find out what will be values of u, of our original variable for this two periodic solution. U naught is sine squared pi theta naught, which is sine squared pi over 3. Sine of pi over 3 square root of 3/2, then it will be 3/4. U1 equals to sine squared pi theta 1, which is sine squared 2 pi over 3. And eventually this also equals to 3 over 4. So this is equal to, remember, it is U2. U2, this is second fixed point. Second fixed point in logistic map. And let's consider third case. Theta node is irrational. As an example, I will take theta node square root of 2 mod 1 without integer part. In binary, its binary representation will be like this: 0.011, 0101, 00, and so on. So it will be fractional number in binary representation. So this is in binary representation. So what is important for irrational number? For large enough n, we don't know what is an. So it is, we have no idea. So since we don't know exact value of irrational number, we don't know what digits, what kind of digits appear at kind of places far, far away. So in different binary places, it's different, and decimal places also. And since we don't know this, so theta n is unknown. And this means that we have chaos. So conclusion is, if theta node is irrational, then the dynamics is chaotic. So what we concluded? We concluded that dynamics depends on initial value of theta. So if theta node is terminating rational, then our solution converges to 0. If theta node is repeating rational, then we will have periodic dynamics. If theta node is irrational, then we have chaos.